Hi students, in this video we are going to understand the concept of quadrant diagrams. So in inverse trigonometric functions, one of the basic skills that you need to develop is to simplify T inverse of T. To simplify T inverse of T of X. For example, you may be asked the value of sine inverse of sine 5. Because the inverse trigonometric functions are not the complete inverses of the trigonometric functions, sine inverse of sine 5 is not exactly equal to 5. Because we know that sine inverse of sine x is equal to x only if x belongs to the range of sine inverse, which is minus pi by 2 to plus pi by 2. That means sine inverse of sine 1, here 1 means 1 radian. So sine inverse of sine 1 will be equal to 1, but sine inverse of sine 2 will not be equal to 2. Because sine inverse and sine doesn't cancel each other exactly when this number is outside minus pi by 2 to plus pi by 2. Minus pi by 2 means around 1.57 to plus 1.57. So if sine inverse of sine 5 value is asked, many students will feel slightly apprehensive about how to find the value of this. So it's not a very difficult question if you understand the concept clearly. So this is going to be quite easy. So the questions that examples that I will make you understand is sine inverse of sine 5, cos inverse of cos 5. This number might change, and instead of sine inverse of sine, it may be cos inverse of cos, maybe tan inverse of tan, or maybe cot inverse of cot 5. Maybe this can be 5 or 10 or 15, whatever it is. So these values can be found out using two different methods. One is by using quadrant diagrams. The second is by using the graphs of sine inverse of sine x, cos inverse of cos x, tan inverse of tan x, so on. So let us try to understand the concept of quadrant diagrams in this video. So how do we use quadrant diagrams? It's quite simple. So you follow the steps that are outlined here. So for example, you want sine inverse of sine 5. Okay, so you draw the quadrant diagram for sine inverse of sine. So the first step in the quadrant diagram is you just have to draw the coordinate axis. Okay, so once you draw the coordinate axis, then what you should do is you have to mark the signs of the trigonometric function sine. You know about ASTC, right? All, sine, tan, cos. In the first quadrant, all ratios are positive. In the second quadrant, sine is positive. The third quadrant, sine is negative. Fourth quadrant, sine is negative. And what is the range of sine inverse? Range of sine inverse is minus pi by 2 to plus pi by 2. So once you mark these three, you draw the x-axis and y-axis. You take the signs of the trigonometric ratio and you mark the range of the inverse trigonometric ratio. So once you do this, the quadrant diagram is ready. So for example, what is the quadrant diagram for cos inverse of cos? Maybe let us calculate cos inverse of cos 7. So before that, you draw the quadrant diagram. So draw x and y axis. So take the signs of cos, plus, minus, minus, plus. And what is the range of cos inverse? 0 to pi. So once you mark this, the quadrant diagram for cos inverse of cos is ready. Similarly, tan inverse of tan quadrant diagram. So maybe, for example, if you want to find tan inverse of tan 10. Okay, so to do this, we start with the quadrant diagram of tan inverse of tan. So how do you draw the quadrant diagram for tan inverse of tan? So draw x and y axis. Then mark the signs. Tan signs are plus minus, plus minus. And what is the range of tan inverse? Minus pi by 2 to plus pi by 2. So this is the quadrant diagram for tan inverse of tan. What is the quadrant diagram for cot inverse of cot? Again, plus, minus, plus, minus. And what is the range of cot inverse? 0 to pi. So from these steps, you can see that the quadrant diagram for cosecant inverse of cosecant and sine inverse of sine be same, because the signs of cosecant and sine are same and the range of cosecant inverse and sine inverse is same. And secant inverse of secant quadrant diagram will look exactly same as cos inverse of cos diagram. So now using these quadrant diagrams, we can find or simplify T inverse of T type questions. So let us go to the next page. So let us do some sample questions. First, let me calculate the value of sine inverse of maybe sine 10 maybe. I want sine inverse of sine 10. So first what I do is I'll draw the quadrant diagram for sine inverse of sine. So plus, plus, minus, minus, and identify the range of sine inverse. Now once you have this quadrant diagram, then the process is quite simple. So what we do is, so first we start with the initial position of the ray and rotate the ray through whatever angle is given here. So sine inverse of sine 10, no unit is given, so the obvious units are radians. So you have to rotate this ray from the initial position through 10 radians. So you know the values. So if you rotate till here, it is pi radians. Pi is around 3.14. So now again one more pi radians. 2 pi radians have been rotated. So 6.28. Next, one more half rotation. So 3 pi. 3 pi is 3.14 into 3. So 9 maybe 42 radians. So you have gone through 9.42 radians, and 10 radians is slightly more than this. So the ray is going to stop in the third quadrant. So whatever angle is given here, you keep on rotating and you have to identify the quadrant in which the ray stops. So clearly after 1.5 rotations, the ray stops in the third quadrant. So now once you draw the final ray position, there can be two cases. Case one is the ray might stop in the quadrants corresponding to the range of the corresponding inverse trigonometric function, or the ray can stop outside the quadrants corresponding to the range. So in this case, we are in case 2. That means the ray has stopped outside the quadrants corresponding to the range. Now once the ray stops, if the ray stops outside the range, you have to reflect it into the range. So the reflection can be done in 3 ways. The ray can be reflected about x-axis, the ray can be reflected about y-axis, or the ray can be reflected about origin. So the decision of how to reflect this is done like this. So if the ray stops in the quadrant corresponding to a negative sign, you have to reflect it into the quadrant corresponding to the negative sign itself. So the signs have to match. So here if you reflect it about x-axis, the signs are changing. If you reflect it about origin, the signs are changing. So for sine inverse of sine, the reflection has to be done about y-axis. So this ray has to be reflected like this. So once you do the reflection, the final ray is ready. The basic angle corresponding to this ray is going to be the answer for sine inverse of sine 10. So this angle is going to be the answer. So you have to calculate what this angle is. So how do you calculate this angle? So from basic understanding of angle, so from here to here, this total angle is 10 radians, and from here to here, the angle is 3 pi. So this small angle is 10 minus 3 pi. So by laws of reflection, if this is 10 minus 3 pi, this is also magnitude wise 10 minus 3 pi. But this angle is calculated in the clockwise direction. So clockwise angles are negative as we know it. So this angle is minus of 10 minus 3 pi. So sine inverse of sine 10 is 3 pi minus 10. So that's the answer to sine inverse of sine 10. So now let's do the same thing for cos inverse of cos 10. So let's solve cos inverse of cos 10. So how much is cos inverse of cos 10? So draw the quadrant diagram for cos inverse of cos plus minus minus plus, and what is the range of cos inverse? 0 to pi, right? The quadrant diagram is ready. Then let us rotate the ray through 10 radians. So same rotation, you rotate this and you can clearly see that the ray again has stopped outside the range. So if the ray stops outside the range, you have to reflect it into the range. So this time we are in negative quadrant, we have to reflect it into the negative quadrant, right? So the reflection has to be made on x-axis. So the reflected ray is like this. So the answer to cos inverse of cos 10 is the angle, basic angle correspond to this ray. Basic angle always is measured from the initial position. So this angle is the answer. So how do you get this angle? The same way as we have done this. So this small angle is 10 minus 3 pi. So based on laws of reflection, this angle is also 10 minus 3 pi. So this angle is pi minus of 10 minus 3 pi. So the answer to cos inverse of cos 10 is 4 pi minus 10. So I hope things are pretty clear. So now the third, same example, let's go for tan inverse of tan 10. So the difference is that we'll draw the quadrant diagram for tan inverse of tan, right? And the ray position doesn't change because 10 is 10. So the ray is like this. But here the reflection, we are in the positive quadrant for tan. So the reflection has to go to the positive quadrant. So this time the reflection has to happen about the origin. So that will be the reflected ray. So this angle is going to be the answer for tan inverse of tan 10. So this angle clearly, so this is 10 minus 3 pi. By laws of reflection, vertically opposite angle is same. So this is 10 minus 3 pi. So tan inverse of tan 10 is 10 minus 3 pi. So what will be the final, let us go for the final one more example, cot inverse of cot 10. So let us go for cot inverse of cot 10. So fourth, cot inverse of cot 10. So what is the quadrant diagram for cot? Plus minus plus minus. So this is the range correspond to this. So now let us get the ray. So the ray is like this. Now again the reflection has to happen about the origin because plus plus. So this is the reflected ray. This has come into the range. So once the reflected ray comes to the range, the basic angle corresponding to the reflected ray is the answer. So this answer is also 10 minus 3 pi. So cot inverse of cot 10 is also equal to 10 minus 3 pi. So I hope the concept of reflection is clear. So this is a very useful shortcut to find T inverse of T of x type questions. So now let us take one more angle. Maybe let us go for sine inverse of sine 9 radians, for example. Sine inverse of sine 9. So if you want to do this, so let's go for the quadrant diagram for sine inverse of sine. So plus plus minus minus. So that is the quadrant diagram for sine inverse of sine. So now let us rotate the ray. So 9 radians, I think you can see that 9 radians ends in the second quadrant, right? So this complete 1.5 rotation is 9.42 radians, as we have seen. 3 pi 9 point how much 3 pi is 3.14 into 3, 9.42 radians, slightly less than 9.42 radians. So you will stop in the second quadrant. Now for sine inverse of sine 9, the ray is still outside the range, so you have to reflect it. So the reflected ray will be like this, plus 2 plus quadrant. So this angle is the angle which is the answer, right? So what is the magnitude of that angle? So how do we do it? So from here to here is 9 radians. From here to total is 3 pi radians. So this small angle is 3 pi minus 9 radians. So by laws of reflection, 3 pi minus 9 will get carried over here. So this is 3 pi minus 9 radians, right? So sine inverse of sine 9 is 3 pi minus 9. So I hope this is clear. Now, what is cos inverse of cos 9? So let us go for cos inverse of cos 9. So cos inverse of cos 9, let us draw the quadrant diagram, plus, minus, minus, plus. So this is the quadrant diagram for cos inverse of cos. So we have taken x and y axis, we have put the signs of cos, and the cos inverse range is 0 to pi. So now let us draw the ray position. So ray position is like this. The ray has stopped in second quadrant. But as you can see, the second quadrant is within the range. So we don't need to do the reflection. So whatever is the basic angle correspond to this ray is the answer. So the answer now will be this angle. So how much is this angle? So clearly from the above, so we have seen that this particular angle is 3 pi minus 9 radians. So this angle is clearly pi minus of 3 pi minus 9, which is equal to 9 minus 2 pi. So cos inverse of cos 9 is 9 minus 2 pi. So whenever the ray stops within the range, so you can skip that step of reflection and take this ray as the final ray. But the answer to T inverse of T of x is the basic angle corresponding to that ray. Basic angle in the sense the angle should be measured from the positive x-axis. So if it is in the counterclockwise direction, you have to report it as positive angle. If the rotation is in clockwise direction, you have to report the angle as a negative angle. So now if you understand this very basic concept of quadrant diagrams, you should not have any problem getting the values of T inverse of T of x. So just before concluding the video, so let us just take one more example. For example, sine inverse of sine maybe 15. Sometimes if a bigger angle is given, first you need to decide what is the relation of 15 with n pi's. So let us first do some basic calculation. So 3.14 is pi. So into 4. So 3.15 into 5 is slightly more than 15. So 3.14 into 4 is 12.56. 12.56, and how much is remaining from 15? 2.44 radians. So 2.44 radians. Pi by 2 radians is like 1.57. 90 degrees is pi by 2 radians, 1.57 radians. So you have 4 pi plus a pi by 2 plus some angle. So let us go for the quadrant diagram of sine inverse of sine. So plus, plus, minus, minus. So now let us rotate this. So 15 radians. So 2 pi, 4 pi. Now we are at 12.56 plus 2.44 radians. That means plus 1.57 pi by 2 plus some radians. So the ray has stopped after 2 rotations and a pi by 2. You have stopped at the second quadrant. So clearly this ray is outside the range. So we need to do the reflection. Reflection is about y-axis clearly. So the angle correspond to this ray is the answer. So what is this angle? So this angle is 2 pi, 4 pi, total is 5 pi minus 15 radians. So this is 5 pi minus 15 radians. So the same angle, this angle will also be 5 pi minus 15 radians. So sine inverse of sine 15 will be equal to 5 pi minus 15 radians. So it's quite easy. So I hope you understood this process. So this is one of the process to simplify t inverse of t. So there is another process which is equally easy, which is based on our understanding of graphs of sine inverse of sin x. In fact, it will be more easier than this if the numbers are big. It depends on our personal choice, personal preference. So we will look into that in another video. So for now, this is what we are going to deal in this video. Thank you.